Okay, in this problem we want to find the integral from 0 to 3/2 of x squared over the square root of 9 minus x squared. And we're going to do this by using a trig substitution, and we're actually given it in this one, although you should be able to figure that out if you weren't given that, because this is has a form of a squared minus x squared, where a is 3. So the substitution for integrals that contain something of that form in the integrand is x equals 3 sine theta, or x equals a sine theta, but 9 is equivalent to 3 squared. So once you get your substitution, then we compute dx. So dx would be 3 cosine theta d theta. And because this is a definite integral, I've also got to, I think it'll be easier anyways, to convert my limits of integration to thetas as well. So my lower limit here is when x is 0. When x is 0, we'll solve this equation for theta. So we would have 0 equals 3 sine theta. So 0, where does sine theta equals 0 is the question, or sine inverse of 0, which is 0. So our new lower limit of integration will be from theta equals 0, and then the upper limit would be x is 3/2. Plugging that into this equation right here. That's what I'm plugging into here. And here, to solve for theta, we'll get 3/2 equals 3 sine theta. So if we divide both sides by 3, we get, where does sine of theta equal 1/2? Sine inverse of 1/2 would be pi over 6. So we're actually going to integrate from theta equals 0 to theta equals pi over 6. So rewriting our integral in terms of theta then, it's the integral from 0 to pi over 6 of x squared is 3 sine theta all squared, or 9 sine squared theta, over the square root of 9 minus x squared, so 9 minus 9 sine squared theta, dx. dx is equal to 3 cosine theta d theta. I'm going to put my 3 cosine theta up here in the numerator and my d theta out there on the end. And now we're going to simplify. So we have the integral from 0 to pi over 6 of. Now the reason we do the trig substitution is because we have a difference of two terms which we can then convert into a single term by using the Pythagorean identity. But first we need to factor out a 9 before we can apply that. So factoring out a 9 from under the radical, I get 9 times 1 minus sine squared theta. And then we can convert the 1 minus sine squared theta into a cosine squared theta on the next step. Up here in the numerator, simplifying, I've got 27 times sine squared theta cosine theta d theta. Okay, so now for the identity, it says sine squared plus cosine squared equals 1. So 1 minus sine squared theta is equal to cosine squared theta. And that's the whole reason we do this trig substitution, because then we can take the square root of cosine squared theta, but we cannot take the square root of a difference. Okay, so substituting that in and simplifying a few other things as we go, we're going to have square root of 9 is 3. Square root of, well, we'll have the square root of cosine squared theta by that identity, which of course the square root and square will cancel, but I'll just do that on my next step. Okay, so we now have, let's see, 27 over 3 is 9. Let's pull that out front. So 9 times the integral from 0 to pi over 6 of. Now let's take a look at this. We've got sine squared times cosine over the square root of cosine squared simplifies to cosine, so that's going to cancel with that cosine. So we're actually just integrating sine squared theta, d theta. Okay, so you could use a reduction formula, or I'm going to rewrite it using a half angle identity, which says sine squared theta is 1 minus cosine of 2 theta over 2. And I'm going to pull the over 2 out front to get 9/2. And then the sine squared theta, the numerator of the half angle identity, says that is equivalent to 1 minus cosine of 2 theta. Okay, from here, that's more easily integrable. And so we have 9/2 times, okay, the integral of 1 is theta. Now for the integral of cosine of 2 theta, I'm going to do this a little bit in my head, but what I'm doing is u is 2 theta, so du is 2 d theta for that integral, so you multiply by 2, which becomes part of your du, but also a 1/2 to balance that, and the 1/2 will remain in front of the integral, so you get 1/2 times the integral of cosine is sine, so we'll have -1/2 times sine of 2 theta. We're going to evaluate this from 0 to, oops, that should be pi over 6. I wrote 2 up there, but that's a pi over 6. Okay, so now we have 9/2 times pi over 6, plugging in the upper limit, -1/2 times sine of 2 times pi over 6 would be pi over 3, minus, when I plug in my lower limit 0, I'm going to get 0 minus sine of 0 is 0, so that's just 0, that entire term. We're almost there, so well, let's do it over here. So we have 9/2 times pi over 6, whoops, pi over 6 minus 1/2 times sine of pi over 3. So we need to fill in pi over sine of pi over 3 here. It's going to be √3 over 2. And that's all. So then continuing on, let's simplify, and I'll go ahead and distribute this 9/2. So this is going to become 9 pi over 12 minus 9/2 times this fraction will be 9 times √3. We have 2 times 2 times 2, so over 8. So the 9 over 12, I can take 3's out. That's going to simplify to 3 pi over 4 minus 9 times √3 over 8 as our final answer for that trig substitution.